Conditional probability is the probability of the event occurring given that another event has already occurred. So this phrase, given that, is the basis of conditional probability. So we denote it as the probability of B given A. All right, see that straight up and down line? That reads given that. So the probability of B happening given that A already happened. So an example would be 2 cards selecting in sequence from a standard deck. Find the probability the second card is a queen given that the first card was a king, assuming that the king is not replaced. If the king had been replaced, then this wouldn't be conditional probability. So your second card being a queen wouldn't have anything to do at all with the first card being a king. But once you don't put that king back, now that changes the total number of cards, and so that's important. So because the first card was a king and not replaced, the remaining deck has 51 cards, 4 of which are still queens. So the probability of second card being a queen, given that the first card was a king, is 4 out of 51, 4 queens out of 51 cards, which we do generally divide that out and take it to however many decimal points you've been asked to give. In ALEKS, if it doesn't tell you to use either a decimal or a fraction, it doesn't matter. You can use whichever one is more convenient. But be careful to notice whether it told you a certain one to use. Okay? Be careful to notice whether or not it told you. Now we have multiplication rules. Remember, we started off with addition rules. Multiplication rules are generally the and, okay? The and, or the intersection. So if your events are independent, the probability of A and B is simply probability of A times probability of B. Remember that, I'm going to spin up to my slides here real quick. Remember that on our addition, the probability of A or B was addition. A or B was addition. Probability of A and B is multiplication. So I'm going to type that here so it stays probability parentheses A or B is addition. Probability of A and B equals multiplication. I wonder what I put there. The B with the parentheses, I guess, turned into a smiley face with a sun. I'm not 100% sure of how to not get that. Let me see if I can make a space or something. Probability of A or B, I'm going to do a space, would give you addition. There we go, that's better. Oh, no, look, I did it again. Ah, goodness. There we go. If I make a space in between, then it will give me the rule that I need. Okay? Probability of A or B is addition. Probability of A and B is multiplication. The multiplication rule. So here we have our rule. A times B. So here we have an example. A spinner has 10 equally sized sections, 3 of which are green and 7 of which are yellow. The spinner is spun, and at the same time a fair coin is tossed. What is the probability that the spinner lands on green and the coin toss is tails? So the probability of green is 3 out of 10 because 3 of the sections are green out of the 10 sections. And the probability of tails is 1 out of 2, which of course is 0.5. So using the multiplication rule, the probability of green and tails, you just multiply those two decimals together, 0.3 times 0.5, and we get 0.15. So that's an example of using the multiplication rule to find the intersection of A and B.